Hi friends, don't let the fear of losing be greater than the joy of winning. A path line is a trace of the path that a fluid particle has traveled. Unlike the previous question, this time the particle goes through an unsteady flow. Well, we are asked to draw the path line of the particle. This question is quite short. Is it really that simple? Before going to the discussion sheet, let's get to know some important equations for calculating the path line. Here is a fluid flow. In this fluid particles flow. The trace of the path passed by the particle is the path line. Let's say the particle's velocity field is u I hat plus v j hat plus w k hat. U, v, and w are component vectors on their respective axes. If we have ever studied motion kinematics, the velocity component on the x-axis is dx dt. The velocity component on the y-axis is dy dt. And the component on the z-axis is dz dt. After knowing the values of u, v, and w, we should be able to calculate the position of the fluid particle at a certain time. Let's look at our question again. There we have a velocity field. Notice the velocity component on the y-axis. There is a t quantity there. This means that the value of this component will change with time. This is an unsteady flow, because at the same point, the velocity value will always change. Let's just write the equation for the position of the particle in a space. We start from the abscissa value, u is equal to dx dt. From the problem sheet, the value of u is -2. This is an easy calculation. Write our equation like this. Then integrate both sides, from the initial condition to a certain condition. Initially the particle is at point 1. The integral on the left side is x. The integral on the right side is t. Now, enter the upper and the lower boundaries which are applied to the integral function. X is equal to -2t plus 1. This is the abscissa position of the particle at a certain time. For the ordinate, v is equal to dy dt. The value of v is 4t. We can write this equation like this. Then integrate both sides. The integral of 1 with respect to y is y. The integral of 4t with respect to t is 2t squared. Enter the limits of integration. Y is equal to 2t squared plus 2. This is the ordinate position of the fluid particle. At a certain time, the particle has a certain abscissa and ordinate position. This is a parametric equation. We can create a table containing 3 columns, time, abscissa, and ordinate. Then place the points into a 2-dimensional Cartesian coordinate system. Initially the particle is at 1, 2. 1 second later the particle is at -1, 4. At t equals 2 seconds, the particle is at -3, 10. And so on. It looks like the path line is parabolic. If you have time to calculate the streamline equation. For each time, the shape of the streamline also always changes. It is clearly seen that in unsteady flow, the path line does not coincide with the streamline. The direction of the particle's velocity is indeed in accordance with the streamline. However, the particle does not pass through the streamline. Happy learning, everyone.
I like to be educated, but I'm so frustrated.